Good morning, dear students. In previous periods, we were discussed about the entire chapter of is matter around us is pure. After completion of second chapter, let us see third chapter, atoms and molecules. Introduction part. Ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. The idea of divisibility of matter was considered long back in India around 500 BC. In Indian philosopher Maharshi Kanada postulated that if we go on dividing matter, we shall get smaller and smaller particles. Ultimately, a time will come when we shall come across the smallest particle beyond which further division will not be possible. He named these particles Paramanu. Yes, my dear students, in previous class, it means in an 8th standard, all of you already learn how the word Paramanu or atom is invented. Yes, my dear students, first of all, the word Paramanu was invented by ancient Indian philosopher Maharshi Kanada. Yes, all of you already know the story. Okay, what happened? He nibbled food item, last left indivisible matter, it means padartha, that is termed as what a Paramanu according to Maharshi Kanada. He named as what a Kana. Yes, another Indian philosopher Pakuda Katayam elaborated this doctrine and said that these particles normally exist in a combined form which give us various forms of matter. Yes, my dear students, after Maharshi Kanada, another one Indian philosopher Pakuda Katayam, what a decorate particles are normally exist in a combined form which gives us what a various form of a matter. Yes, in the same era, it means around the same era, ancient Greek philosopher Democritus and Luciferus suggested that if we go on dividing matter, a stage will come when particles often cannot be divided further. Democritus called these indivisible particles atoms. Yes, my dear students, it means after, it means not after, in the same era. It means around 500 BC. At that time, ancient Greek philosopher Democritus as well as Luciferus suggested the word what a atom. Atom is nothing but what a smallest indivisible particle, meaning is indivisible. All this was based on philosophical considerations, not much experimental work to validate these ideas could be done till the 18th century. Yes, my dear students, it means these all are say what a philosophical base, not experimentally proved. Yes, by the end of the 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding out how and why elements combine and what happens when they combine. Yes, my dear students, in a last chapter, we already discussed the definition of element as well as definition of compound. When it started, it was started in an 18th century. Yes, in the end of the 18th century. At that time, scientists are know what the definition of elements made up of what same kind of a matter. They are termed as a element. Compound means more than two elements are chemically combined with the help of what integral ratio, they can form a compound. Afterwards, Antony Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. Yes, my dear students, let us see laws of chemical combination. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. They are as follows. They are, first one, law of conservation of mass. Law of conservation of mass, and second one, law of constant proportions, or law of definite proportions. Law of constant proportions or law of definite proportions. Yes, my dear students, let us see. First one is law of conservation of mass. First one, law of conservation of mass. Yes, law of conservation of mass states that mass can neither be created nor be destroyed during a chemical reaction. Yes, my dear students, in any type of a compound form or chemical reaction is takes place, at the time mass can neither be created, means not able to create as well as not able to destroy. That is termed as what? Law of conservation of mass. Yes, this means that in any chemical reaction, the total mass of the reactant is equal to total mass of the product, and there is no change in mass during the chemical reaction. Yes, my dear students, law of conservation of mass states that mass can neither be created nor be destroyed during a chemical reaction. Yes, it states that mass can neither be created nor be destroyed during a chemical reaction. It means that, my dear students, in any chemical reaction the total mass of the reactant is equal to the total mass of the product and there is no change in mass during the chemical reaction. Yes, it means, take an example. Sodium carbonate plus hydrochloric acid, arrow mark, it can use as to carbon dioxide plus sodium chloride. Yes, my dear students, here sodium carbonate is 4.0 gram and hydrochloric acid is 10 gram. Yes, formation of carbon dioxide is 2.5 gram and sodium chloride is 11.5 gram. Yes, according to statement, what here mass can neither be created nor be destroyed by chemical reaction. Yes, my dear students, here in an reactant side, here 4 gram and 10 gram, 4 plus 10 it is equal to totally 14 gram. Here it means in product side carbon dioxide is 2.5 plus sodium chloride is 11.5. Yes, it is equal to how much? 14 gram. 14 gram. Yes, my dear students, it mean what in any chemical reaction the total mass of the reactant, total mass of the reactant is equal to the total mass of products. Yes, my dear students, it means here is also 14 gram in reactant side as well as in product side 14 gram. Therefore, there is no change in mass. There is no change in mass during the chemical reaction, It is clear? Yes, my dear students, law of conservation of mass is nothing but what a mass can neither be created nor be destroyed during a chemical reaction. Yes, my dear students, example is taken here. Sodium carbonate is 4 gram as well as hydrochloric acid is 10 gram. Yes, what is obtained here? 2.5 gram of carbon dioxide as well as 11.5 gram of sodium chloride. Yes, in an total mass of the reactant is 14 gram as well as total mass of the product is 14 gram. It means total mass of the reactant is equal to the total mass of the product. It means therefore, there is no change in mass during the chemical reaction. Yes, my dear students, it is the first law of chemical combination. Law of conservation of mass. Yes, let us see law of constant proportion. Second one is law of constant proportion or law of definite proportion. Yes, let us say second one, law of constant proportion or law of definite proportion. According to this law, in a chemical reaction, the elements are always present in definite by mass. Yes, my dear students, it means the mass is definite or constant where in any chemical reaction. Yes, the law states that it means law of constant proportion states that in a chemical substance or compound, the elements are always present in definite proportion or ratios by mass. Yes, my students, the law states that it in the law of constant proportion states that in a chemical substance or a compound, the elements are always present in different proportion or ratio by mass. Example, in a compound such as water, the ratio of mass of hydrogen to the mass of oxygen is always 1:8. Always 1:8. It means whatever the source of water, thus if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Yes, my dear students, what happened here? The process of decomposition takes place. Yes, where in a 9 gram of water can give rise to 1 gram of hydrogen and 8 gram of oxygen are always obtained because in a chemical substance or compound, the elements are always present in different proportions or ratios by a mass. Here water mass is by mass is 1:8. Example, water, yes, hydrogen 1, oxygen 8. Yes, if 9 gram of water, if 9 gram of water is decomposed, hydrogen, 1 gram of hydrogen decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Why? Because they are present in what a different proportion as well as a different or definite ratios by mass, because they present definite proportions or ratios by mass. Yes, my dear students. Okay, this is the second law of chemical combination. Second law of combination, laws of constant proportion. Yes, my dear students. Afterwards, according to Dalton's atomic theory, all matter, whether an element, a compound or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as, yes, my dear students, next Dalton's atomic theory. Let us see Dalton's atomic theory. Third one, our next discussion point, Dalton's atomic theory. According to Dalton's atomic theory, all matter, whether an element, a compound or a mixture is composed of small particles called atoms. Yes, my dear students, it means all matter, whether an element, it may be a compound or a mixture, is composed of what? A small particles called atoms. The postulates of Dalton atomic theory are as follows. First one, all matter is made up of very tiny particles called atoms. It means they are made up of what? Very tiny. It means small or indivisible particle called what? Atoms. Second, atoms are indivisible particle which cannot be created or destroyed in chemical reaction. Yes, already all of you know. Atoms are what? They termed as indivisible particles and which cannot be created or destroyed in a chemical reaction according to first law of chemical combination, law of conservation of mass. Yes. Third postulated, atoms of a given element are identical in mass and chemical properties. Yes, my dear students, here each and every, it means 100 elements, 118 elements, they have what? Their identical mass and as well as their own chemical properties. And fourth one, atoms of different elements have different masses and chemical properties. Yes, my dear students, here different elements have their what? Their different mass number as well as masses and their chemical properties. Fifth postulate, atoms combine in the ratio of small whole number to form a compound. Yes, atoms combine what? A small whole number and they can form a new compound. And sixth one, the relative number and kinds of atoms are constant in a given compound. Yes, my dear students, relative number as well as their kinds of atoms are constant where in any type of a given compound. In today's class, we all are discussed about introductory part of atoms and molecules. Yes, afterwards Anthony Lavoisier laid the foundation of what? Laws of chemical combination. There are totally 2 laws of chemical combination. First one is law of conservation of mass and second one is law of constant proportion. Afterwards, we all are discussed Dalton atomic theory and postulates of Dalton atomic theory. Yes, thank you dear.